let me now introduce Dr. Jie-Qi Chen, Founding Executive Director, Early Teaching and Learning Academy. She has done extensive research in the field of early childhood for past 34 years, especially with regard to mathematical skills, and has been instrumental in proposing various educational policies. She has developed teacher training and teacher development programs in early childhood based on the theories of Howard Gardner. May I now invite Jie-Qi Chen, ma'am.
Good morning, everybody. My talk today is about early mathematics education, the why, the what, and the how. The why is about the importance of early math, and the what is about the content, where the how is about the pedagogy. Okay, if you look at our program, and our program start with the early childhood education. And this is a very developmentally appropriate because we know the foundation of early education, right? And our esteemed speaker just talked about, based on the research, we know the early years builds a strong foundation. If we have a strong foundation, and then we can build a stronger and stable and a tall building. Then I'm going to talk about mathematics in the early years. And you probably would say, you came from America, Jie-Qi, and we know Americans are so bad about the math, okay? And in the international competition like PISA, Americans are always at the bottom. Well, we, India, very good in math, okay? We are strong. And we are strong, we produce the best mathematicians and the technology and the experts. And our children from very early on knows the numbers, know number very well. They can count 100, they know the shapes, and they know additions, subtractions, and even multiplications and divisions. So what are you going to talk about, Jie-Qi? I certainly hope I'm going to extend your thinking about what early mathematics is all about and what kind of early mathematics is important in the early years of teaching and learning. So first, we need to know what is early mathematics education. Here I'm giving a definition. The experience designed to help children from birth to 8 years develop 3 things. First, knowledge and skills. That is fundamental. Secondly, attitudes, positive attitudes toward math. I can do math. I'm a good problem solver. And the third one is the ability, is to think about math, is making sense about math, is use math as a tool for problem solving. So now let's focus on the first thing. Why focus on early mathematics? Well, here I'm going to show you 3 research studies. The first one is done by an economist and from UC, University of California, and Irvine. And this is a group of researchers. They studied and what they call a meta-analysis. In other words, they analyzed 20 different studies and the longitudinal studies, and they focus on from pre-kindergarten to 3rd or 8th grade. What they found out is here that is not a surprise to you. And the early reading skills predict later reading skills. And the early math skills also predict later math skills. What a big deal? We know that. What it is surprise is this finding. The early math skills also predict later reading skills and achievement, but not the other way around. This is a very surprise. So the authors conclude First, competition in both domains, both reading and math, is important in determining children's later education and occupational prospects. But mathematics has stronger predictive power than reading for later achievement. Let's look at another study about early math importance. This study is done, again, longitudinal, and then they look at the number system knowledge. Children know the number sense and then knows what number really means and the number relationships. And that knowledge predicts children at the 7th grade in terms of their functional numeracy, meaning that these people, when they grow up as adults, they can really function basic mathematics skills. And also predict retention rate in high school. In other words, these students good in early mathematics number sense, and that they were more likely to finish their high school. And lastly, not surprisingly, and also predict their employability and also wages. Let's look at another study. This study is talking about 3-year-old and 4 years old and 9 months. And the lower line is children from lower income class, okay, poverty children, whereas the green line is the middle class. What you see here is that the two lines parallel. They didn't overlap. What does that mean? It means that if you are start low, it is harder for you to catch up. Okay? That's what it means. Does it make sense? Okay, to summarize, why focus on early mathematics? Math is not a set of knowledge and skills and activities that young children learn to do. It's not just that. It is also a language of a logical reasoning and a computational thinking, okay? It is a process of thinking, sense-making, and problem solving. It's a tool. When we're thinking, we need a tool. Language, like literacy, it is a tool. Mathematics, numbers, and the senses, and the relationship also is a tool. Tool for young children to think about and see and understand the world in a very different way. Now, let's look at what constitutes early math. We know math includes the numbers, shapes, and measurement. But what I'm going to tell you is something a little bit different. This, you will see, is from American's Common Core State Standard, okay? And the mathematics including all these 5 areas. So for each area, I can certainly talk about a day of the content and knowledge. What I'm going to talk about here is different. I'm going to talk about something in the middle, which we call the overarching concept that is supported and also connected with all other 5 areas. Today, I'm going to focus on only one in this concept, which is attribute. What is attribute? Attribute is a quality and characteristics of an object. For instance, color is attribute. And the texture, I have the soft and the close, and the hard, and the materials in my hand. The hard and the soft is attribute. And the tall and the short is attribute. So now let's look at it. And here I have a glass jar. If I ask you, how many ways can you describe how big this object is? Can you tell me how big this jar is? What? Speak louder. How big this jar is? I'm sorry? You need a comparison. Whoa, my goodness. That's a very sophisticated question. But I ask you just this jar. Do you think this jar is big or small? You say you need a comparison. But compare what? Okay? And when we talk about a jar, we can talk about big in terms of the height, in terms of the weight, in terms of the capacity, how much water it can contain, and also the comforts and the surroundings, how big it is. In other words, when we talk about the measurement, we see, oh, big is a measurement concept. A big idea in measurement is many different attributes can be measured, even when measuring a single object. When we measure, we have to have something called attributes to measure. We cannot say, this is big. Big in which way? Let's look at another example. Shape. What kind of shape is this? Triangle. Okay. How about this? Is this a triangle? Yes. It looks so different. Why is it also triangle? How about this? Is this a triangle? Yes. Well, young child might say, it's upside down triangle. But is upside down triangle a still triangle? Yes. Why? Why? Because there's 3 lines, okay? Just 3 lines. I have 3 lines here. Is that triangle? No. Is this triangle? No. There also need 3 straight lines and 3 corners, right? Okay. So these are not triangles, even though they look like triangles, right? So the definition for the geometry here is shape can be defined and classified by their attributes. Triangle attributes, the 3 corners and the 3 straight lines. It doesn't matter what it looks like. If they follow this attribute, it is a triangle. Let's look at another thing. These are a bunch of shoes, students' shoes. I ask you to sort them. Can you give me a way to how you're going to sort them? Speak loud so I can hear you. Shape, colors, beautiful colors. So there's some red colors and there's some green colors. Okay, what else? Size. Okay, some is bigger and some small. Can you give me another way to sort it? So there's another way is that there's some boots and there's gym shoes, right? Gym shoes. So what it says is this. Attributes can be used to sort collection into different groups, different sets, right? The same collection can be sorted in different ways if we use different attributes. You hear me talk about attribute, 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 okay? And so here are a bunch of shoes. We can sort based on the color, based on the size, based on the functions, right? Or many other ways. Let's look at the pattern. That's a very popular in early childhood classroom. Okay, now if you see, what kind of pattern is this? White, green, white, green, white, green, right? Okay, so what is the attributes we're using here? Color, absolutely true. Color is attributes we're using. And this one too. But how about this one? This is a pattern too. What kind of attributes we use sort of that? Shapes. So children need to know that attributes in order to identify this is a pattern. Or if something missing, and here is an AB pattern, this is an AAB pattern, right? Even though they all use the color, but they are different patterns. If children understand this unit, what is repeating, and then they learn about the pattern. Let's look at the number. Number is such a basic in the mathematics and the content. So here, what do we see? We see 3 elephants. They are obviously bigger if we compare 3 mice, right? Okay? They are bigger than mice if we use the attributes of size. But if we use the attribute of a number or numerosity, what will happen? They are identical. Both are 3s, right? So a collection can have many attributes. Here I have flowers. The color is an attribute. Shape, round shape, is an attribute. Smell, oh, delicious smell, is an attribute. Quantity is another attribute. There are 3 roses here. So that's why in the early childhood years, we see number is an adjective. It's not a noun. You always count on something. 3 people, 3 cups, 3 flowers. So it's like an adjective, like a red flowers, 3 flowers. You don't count just the naked number. 1, 2, 3, 4, 5. 5 of 1. Okay? We do not just counting the naked number. We always use number to describe a collection. So, for number sense, a big idea here is quantity is an attribute of a set of objects. We use number to name specific quantities. So, here is what we have just covered. I talk about attribute is an overarching concept that really connected all these areas. So here, this is a much more fundamental, yet more basic number or mathematics concept. So, to summarize, what constitutes early mathematics? High-quality early math education expose children to a range of content areas, but there are a small number of overarching concepts that connect to the content strength, and that is attribute, comparison, pattern, and change. I only talk about the attribute today. Now let's look at how to foster children's mathematics understanding. I'm going to give you a classroom example. Here is a 4 and 5-year-old in Chicago public schools. And the teacher read a book to children. This book called Whose Shoes? It's talk about all kinds of shoes children wear, and everybody has that experience. Then teacher asked children 2 questions. What kind of shoes are you wearing today? If we make a book about the kinds of shoes in our class, how could we organize all shoes? So this is a sorting activity, but this is also a data analysis activity, because we want to see what kind of shoes we are wearing and how we are going to organize. So teacher asked children to put all their shoes, take their shoes up then put into on the floor, and then children start and categorize, sorting them. Then what we're going to see is afterwards. Children already read the book, and they already sort their shoes and put their shoes in the different ways. Now what we're going to see is how teacher to take them to a data analysis and activity. So data analysis, why we do the data? The purpose of collecting data is to answer questions when the answers are not immediately obvious. Okay, so and here, what kind of shoes we are wearing? And we don't know. We have so many people here. We have to organize that and then make that a prediction.
Make it up. Writing.
Yeah, I'm doing some writing. What if I drew a picture of my shoe? Right?
Yeah.
What if I drew a picture of my shoe? And then we could remember what shoe we were wearing today, and we could make a new graph. Do you think we could do that? I wanted the students to draw their shoes instead of just giving them a paper cutout, because I think it gives them more meaning to that abstract representation of their shoe. So when we make the physical graph, it's easy for the children to see their shoe on the graph. It's physically there. You know, they're holding it in their hand. It's concrete. When you start to take a step away from that to be more abstract, the meaning can get lost in children that are at this age. So by having them draw their own shoe, it gives them more ownership. I also think that by drawing the shoe, it helps them to remember how they sorted their shoe in the first place, what the attribute was that they were sorting it in. Because when they're drawing it, you know, I ask them, make sure that you draw your straps, you know, make sure that you draw your strings to help them remember that that's how we had decided to sort the information. Do you see where it says zippers? Okay. Good, zippers.
The reason I wanted the students to help construct the pictograph themselves is that if I'm putting the pictures up on the graph, I'm taking ownership of it. Then it's me sorting the information. If the students are doing it themselves, they're the ones taking ownership of their data, their information. It's their shoe, and if they're the ones putting it on the graph, then it helps them to remember again that this picture represents their shoe. It's just another step in helping them to make that connection between the concrete and the abstract.
Can you look with your eyes and find your shoe on the graph? Look with your eyes.
Mine with the dots on them.
Whose shoe was this picture for?
Mine.
Right. What about this one?
Jasmine.
Jasmine. Okay. And what about this one?
Mine.
Yours, Ashley. What about this one?
Me.
That's yours, Darianne. And this one, whose shoe was this?
That's yours.
Right. So does everybody have their shoe on our picture graph?
Yes.
Yes, we all do, right? So tomorrow when we come back and look, we can remember that these were our shoes. Which of our categories has the most shoes?
The string.
Right, the strings. How do you know it has the most shoes? Because it's all the way up to the top. Well, let's count and see how many shoes or boots have strings. Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Right. So here's my question. If we did this graph on a different day when it was hot outside, what do you think would be different about our graph?
They can wear flip-flops in school.
Right, we might have flip-flops on if it's hot outside. Right. You're right.
And we can wear sandals.
We could have a category with sandals. What I want to do is I want to keep our graph here so that we can talk about it a different day.
When talking about our data display, I thought it was important to ask questions that will lead the children to think about what's the meaning of this data today and how might it be different another day. That's the reason that I asked the children to think how this graph would be different if it were made on a hot day. And part of that came from the books that we have read yesterday about shoes. The book Whose Shoes was a good lead-in for that question, I think. But getting the children to think about that graphing is a way of organizing information at a specific time and in a specific place. You know, the information that we graph today is going to be different on any other day. And it's important for them to think about that kind of mental idea as
here I want to capitalize and how, and in terms of the pedagogy of how to teach mathematics. And here's the triangle. And you look, there's actions, there's images, and there's a symbol. Okay, and let's go one at a time. And first, let's talk about the actions or manipulatives or your body movement. And the manipulatives, and I think it's common in early childhood classrooms. When we think about the math, we always think about we need manipulatives. Manipulatives is very important because it supports children's concrete thinking. But let's look at, and when we talk about the math is actually very abstract. When we talk about the concept of fourness, that four really is not just one kind of four. It includes many different kinds. Okay, so here we have a pet bear, and we have a cups, we have unifix cubes, and they are different in terms of the color, in terms of the shape, in terms of the type. But they are all fours. That is the abstract from the concrete. Okay? Then another thing, we talk about the concept of fairness and the fair share. That is the precursor concept of division. Okay? Again, you see, in terms of the color, in terms of the shape, in terms of the type. And there is a distance between the concrete to the abstract. That's why we see manipulatives does not equal math concept. Because as Deborah Ball talked about, although kinesthetic experience, hands-on experience can enhance perception and thinking, understanding does not travel through the fingerprint up to the arm and to your head. Mathematics idea really do not reside in a cardboard and plastic material. So what is needed? It needs language. It needs language to explain the connection between concreteness and abstract ideas. So, and the second part, we talk about the triangle, is the image. And I'm going to talk about the language in the end. And lots of children's books include mathematics ideas. When we use children's book to talk about the mathematics ideas, and the mathematical ideas become alive with the characteristics and with characters and with content. And here, and the Anno's counting book is about the number, and this is about the sorting and the pattern, and this is about, and the mapping house, it is about increasing pattern, okay? And images also including graphs, and we have an object that is more concrete, but if we use the number and the lines and the pie graph, that is more abstract. But all these help children to keep their image in their mind. And also visual math, and we talk about the number lines. So when children say 1, 2, 3, 4, that 1, 2, 3, 4, 5, 6, 7, 10 is very different from A, B, C, D, E, F, G, because that 5 does not only means the number 5, but also means as a collection, the cardinal number. So when you have this number line, which helps children think about 10 is going to the other side, okay? So the more and the other side is the larger number. So the number line also helps children to build number sets. And here is another different materials with visual math. And for instance, and the 5 frames and 10 frames, and all these things is useful. Let me see, how many is here? 3. How many? 4, excellent. How many? 9. You're so good. 9. How many? What is on the top? Also 9. How come you know it? Is it harder when you have this whole line than when you have a 3 line, right? Why is that? Why? Both are 9. One is harder. Let's look at this. How many? That's also 9. Okay, so there's 3 different ways to display 9. When you have a 3 and a 3, and it's 9 because it is our experience. We know number when you have a 3, then you get it. When you have a one very long line, it is harder for you to count from left to the right. When you have it all displayed randomly, and it's even harder. Okay, so how you display the dots helps children to organize their thinking. The important thing is this, and we have a left brain and the right brain, and the mathematics learning and the performance was optimized when the 2 areas of brain were communicated. So our left brain and the right brain, one is more abstract thinking, the other is more visualized. So we want to make this connection together. So that's the second part. The third part I want to talk about is a symbol system. And here is a study. Okay, there's a number of studies, and this is just one. It talks about the number of, the amount of adults' math input in terms of speaking using math-related language could positively correlated with children's math performance. In other words, the more teacher and or parents talk about the math, not just the manipulatives, not just to show them pictures, but the talk, and the talk, and the talk, children's math performance will increase, okay? And so it is very important to think about, and that there are the 3 areas. And these 3 areas, and concrete, pictorial, and the symbol, their connection neither automatic nor static. So it requires intentional teaching to constantly make these connections again, again, and again. So here are 2 books my colleagues and I published. And this one, Precursor Math Concept, talk about mathematics from 0 to 3-year-old, whereas big ideas of early mathematics talk about math from 3-year-old to 8 years old. Okay, so takeaway message is early math is rich and complex, central to children's cognitive development and school achievement. Everyone can and must learn and do math. And the adults play a central role to foster children's mathematical learning and understanding. Questions? Thank you. Thank you. What time is it? I have 5 minutes. Okay, questions? If you have questions, please stand up. Well, if you have no questions, there's 2 possibilities. Either I talked so badly, no one understands, or I did such a good job, everybody understands, so there's no questions. It cannot be the second part. Okay, you have to have questions, so I know, and you're thinking, and we're learning together.
Chen,
Okay.
Dr. Chen, when we do the curriculum mapping here, we also have the concept of time and money, 2 concepts. If you can just tell us, when do we introduce time? At what age do you want us to? Because children find it difficult to understand yesterday and the day before. They understand today and tomorrow better.
Yeah, and in school, and we create, and you see, calendar is often talked about in the school, okay? Calendar is a time, but the calendar is a very confused for young children because, and the calendar is what 7 days is a unit, okay? Then Monday is not always in the January 1st. And the next Monday, and it's going to change. So the relationship is not always constant. It constantly changes. So in the United States, in my project, when we ask the teacher introduce and the school days, we use a school calendar. So it's always a Monday to Friday. The next week is Monday to Friday. We do count the number of days and how many days we're in school, but we do not use regular calendar until elementary school.
I have a question. When you teach or introduce maths in the constructivist methods that you have introduced or you have adopted, how does a teacher do, apart from the observation skills that we have, how does one assess the child in the same kind of methods?
Yes, okay. How teacher can support children to learn mathematics in a constructive way, okay? The most important thing is teacher understand the big ideas of mathematics. Okay, there's lots of activities. If you look at the website, some activity is we call the cute activity, but not really emphasize the big ideas. Big ideas is those ideas that are really central to particular mathematics content and really build a foundation to further learning. For instance, the attributes I just talked about. You see how important that attribute is, right? And the attribute actually is an inborn trait. When children just born, they know what is cold and what is hot, okay? They know their diaper is wet, they are crying. They know they are hungry, they are crying, right? And when you change a diaper, they were happy and then they really shake their head, right? The issue is how do we bring that natural instinct to the mathematics understanding? It is really important. It's not a teacher follows the curriculum because we know curriculum, you have to develop something for everyone. But there is no standard child. There is no average child. And each child is different. It is up to us to understand the curriculum and then adapt that to meet the needs of an individual child through daily life. You don't have to have a really math curriculum, but you do, as a teacher, to understand all of the connections, how this connect this, this connect that, and use your language to emphasize that connection and through activity. Thank you for the good question. Yes.
So what I found here is you do use a lot of manipulatives and you use constructivism. I was wondering, do you have any work connected to movement and math? Because it's about also the physical body, and how are we understanding, because physical body is something known to us the most, is the most concrete thing. And math, like you said, is a language which we are trying to break it down through attributes, like shape, color, smell, other things. So do you have any work related to math and movement? Like, because since you were a researcher, I was wondering what are your findings over there?
Excellent question. Because, and we're talking about the development of the whole child, okay? Development of the whole child, mathematics can help develop the whole child. And the first, and we're talking about the mathematics language, so there's a language there, there's abstract thinking there, there's a collaboration there. But the body, let me give you one quick example. When we talk about the books, and I don't know if you are familiar with a very popular book in the United States called Gingerbread Man, okay? So Gingerbread Man get out of the oven and running, everybody is following, right? What math concept there? It's a counting, It's a sequence. So, and the grandma is out, grandpa is out, right? So how many pieces follow the gingerbread, right? The gingerbread man. So we can have a 1, 2, 3, 4. Counting that. Who is counting? Children can be, I'm grandma, you're grandpa, okay, you are the pigs, and you are the cows. Everybody is following. And so kids really see the line is getting longer and longer. That is add on, right? But I can also change that story. At one moment, the pig said, oh, it's too much, I don't want to run, so I want to stop, okay? And the horse said, oh, I'm so stupid. I don't even like gingerbread. Why I'm running? So I'm sit down, okay? So you have a take away. You can take away 1, you can take away 2, right? So you see, children, the line gets shorter and shorter. In the end, only fox there, and the fox ate the gingerbread. So what is? It's a 0, okay? So that is children's body movement. Help them understand what is add, what is a take away, what is getting longer, what is getting shorter. That's just one example. The napping house I talk about is the growing pattern and the decreasing pattern. You can also have, and the grandma is in the bottom, and then the mouse and all the animals add on, then they take one away. So it is lots of body movement to help children understand the concept of math. Thank you very much. Oh.
Thank you, Dr. Jie-Qi Chen, for that wonderful presentation. May I have on stage our COO, the SSV Malka, to please felicitate the speaker.
Excuse me, ma'am. Can I just have one question? Can it?
Oh.
I'm trying to ask you one question, ma'am, here.
Oh.
Yeah. As generally we use the role play, which is it's the most important thing in the education. Can we introduce role play also in mathematics to teach few concepts?
Can you repeat the question?
As role play makes a very important keynote in the education, can we implement this role play in teaching few concepts of mathematics?
Yeah, I think it's less is more here, okay? If you emphasize all of the things, they are not connected. You don't help children understand, build the understanding. What is understanding? Understanding is the connection. It's to use one concept in many different situations. So what we need to try to help children is not rote memory, it's not just learning different facts, is to build the connection. That is less, and less is more.